Okay, let's get started, everyone. Hope you can hear me. So it's a great pleasure to have a discussion on the climate, mental data, and data for disaster preparedness. We have Dr. Joshua DeVincenzo. He's an assistant director for education and training at the National Science for Disaster Preparedness, which is called NCDP, here on campus at the Columbia Climate School. So they've been doing a lot of nice work. And also an adjunct lecturer in the same center at the NCDP. And you're going to be introducing Shu Young as well, yeah, if you don't mind.
Good afternoon, everybody. Thanks for having us. Fortunate enough to be joined by my colleague, Shu Young Huang, who is a two-time graduate of Columbia University's GSAP, where she studied architecture as well as urban planning. And the reason why I think it's going to be excellent to have Shu Young here is we're going to look at disaster preparedness, the different data that helps inform our decisions from many different vantage points. And Shu Young is going to really anchor the presentation with some of the future directions that could help improve our disaster preparedness response resilience systems in the US, but then also around the world. So we'll also be doing some brief intros a little bit later, but thanks, Shu Young, for being here. And without further ado, I'm actually going to jump right into the presentation because I know time's limited. It's going to be pretty informal. We're going to run through some topics, but ultimately, really just want to give everybody a lay of the land of the disaster space. So disasters, of course, are involving in their complexity, in the data that we do have, the funding, the programs that we have, but then also very importantly, with our perceptions of risk as well as disaster preparedness throughout the world. So I'm going to be combining some of the themes of what we know from cognitive and behavioral sciences to what we're looking for towards the future around applications of artificial intelligence, climate projections to help first responders, emergency managers. So oftentimes disasters specifically are things that we're learning as we go. So we're going to take a moment this afternoon to really pause and think through the existing frameworks, the existing research that we do have that help us better prepare people. Before I jump into the formal presentation, I really want to put the caveat there that when we're talking about disasters, we're really just trying to keep people out of harm's way with a changing climate. That's our first and major priority. We're going to talk about this from a lot of different angles, from the financial side, economic impact analysis, to our built environment, but really having a human-centered, people-centered approach is the core of what our work entails. So we'll dive in with just a brief agenda for today. I believe the slides will be sent out. So again, no need to memorize or capture all this information per se. We definitely just want to bring you up to speed with what we're seeing on our desk, because ultimately at the end of the day, we need collaborators, we need help. You know, there's a lot of very, very passionate and intelligent people working on these issues, but we do need to see our response to the climate impacts, climate crisis as a very distributed and collaborative approach around the world. So we'll do a brief introduction to disaster studies for everybody. I'm going to go into a little bit of our research on mental models and behavioral science for disaster preparedness. So what do we need to do differently or continue to do to make people want to take disasters seriously, to understand risk and the magnitude of some of these events. We're going to talk about emergency managers and climate change, and then we're going to close out the presentation with some of the applications and need for different data sources across the emergency management phases that we'll go into. So first and foremost, I think one of the things that we're seeing where we see the nexus and the intersection of so many disciplines wanting to talk about climate impacts, but then also wanting to talk about climate change more broadly is different frameworks that exist in different fields, right? So in artificial intelligence, data science, we have some of those frameworks that we gravitate towards. Emergency management is no different. And one of the reasons why I want to start here is that the more that we can understand their existing frameworks, the easier it is for us on the periphery or as an adjacent field to collaborate with them, to help them in their decision support sciences and everything in between. So there's 4 phases that we're going to come back to throughout the presentation, because most of how we conceptualize emergency management exists in these 4 realms. The first is mitigation. Actually, I'm sorry. The first one is preparedness, which is talking about anything beforehand, before the disruptive event, the disaster, whether it's a hurricane, a drought, tsunami, any of those major events that you could be thinking about. What can we do in what we call blue sky days? Blue sky days are a lot like today, not a cloud in the sky. We're fortunate enough here right now in this moment not to be thinking about a disaster, where the contrast to that is what we call gray sky days. Those are when a disaster is taking place. where there's going to be a lot of disruption in everyday life, our systems, our lifelines. And people are not necessarily thinking about preparedness in that phase, right? We've already moved to response. So we're thinking about how do we respond to this shock? How do we minimize the impact that's happening to people, to property, to future economic shocks, all in this response side? How do we get people to shelter, to the health that they need? The next phase there is going to be recovery. So after the response, so we're talking about maybe a day, 48 hours after that disaster, what are we doing as a community, as a society to help recover and restabilize systems that might be disruptive, and think about some of these long-term effects that are going to really germane and characterize communities for a long time. We're going to go through a little bit of the disaster continuum around what types of events take place and why this is actually much more complicated than just the cycle here. And then the last one's mitigation. And in the disaster space, we use the word mitigation a little bit different than than in the climate space. So in disasters, when we're talking about mitigation, we're just talking about lessening the severity of another disaster occurring. So what can we do in how we set up our cities, our towns, our communities to better prepare? So it ties very much into the preparedness for the next impact and the level of impact there. So as, I don't want to go right to the punchline here, but as you can imagine from a data standpoint, there's very different types of data that are needed across, as well as the accessibility of that data to inform decisions in this cycle. The other thing to point out is that this is a cycle. Unfortunately, because we're seeing the magnitude severity of these disaster events really continue and pick up, it's no longer a linear thing where we would say, this is the preparedness, this is response, this is recovery, this is mitigation, and then we're good. Unfortunately, with what we're dealing with at a large scale is more of a cyclical nature of the 4 emergency management phases. But things are very complex right now. I think we're all fully aware of this. So even those delineations are becoming a little bit blurred. So this is actually taken from a first responder that we were working with back in 2020 out of King County, Washington. King County, Washington was the first county in the United States to have a fatality due to COVID-19. And this was an experienced emergency manager that, we're used to teaching those phases, saying like, we're here in preparedness, we're here in response, we're here in mitigation. And he rose his hand and was essentially like, are we in response, recovery, resilience? Are we in a combination of all of them? It's hard to say. So when we kind of really dive into these concepts further today, thinking about those delineations, thinking about how to better articulate kind of these compounding disasters that exist. Compounding disasters mean essentially on top of, let's say, a global pandemic, we are still having to think about our decisions, our risk perceptions around wildfires, around hurricanes, flooding, all of the above. So we're seeing a very complex risk landscape that's changing as we speak. So what can we do better around these disaster themes? There's no time like the present to address these. So of course, this is probably no news to anyone here. We're hitting global temperatures almost month to month on a regular basis. But one of the charts that I really want to focus on is over here through NOAA. This is the $1 billion disaster report that comes out. And part of the reasons that now is actually a really important time to start thinking about how we're addressing disasters is because we're getting a lot more support and awareness at a national scale. So these are just the disasters in the US that have crossed that $1 billion threshold. That's not to mention the ones that have not exceeded $1 billion disasters, a million that have not exceeded $1 billion that continue to compound and collect. So in many ways, there's an economic interest, there's a social interest, there's a lot of interest now to figure out how do we mitigate disasters better. And what we'll see here and throughout the presentation is we really need better data to help inform some of these decisions so that we can get ahead of this. And some of the comments usually that we get for the $1 billion disaster report is, are the disasters getting more expensive or are we just putting more expensive stuff in the way? And it's becoming a combination of the two. So even thinking about all these different sectors of society, thinking about how we can mitigate the disaster impacts here. As you can see, it's becoming quite the expenditure to get it wrong. So let's back up real quick, just with some key terminologies and concepts. So first, we have a hazard and we have a disaster. So a hazard is pretty straightforward, right? A hazard is the source or cause of potential harm. So these could be your earthquakes, these could be your fires, these could be your floods, et cetera. But how do we define a disaster? Anyone have any thoughts on how you would define a disaster or what a disaster might mean to you? I know this is the middle of lunch, but any disaster definitions? There's no wrong answers here. Yes, in the back.
It's like a hazard of like a certain scale, I guess. Like once it does X amount of damage, it's no longer a hazard. It's now.
Exactly. So once the hazard harms a person, property, and is kind of actualized, the hazard then transitions into a disaster. But what we do know is sometimes in the academic literature, we get a lot of different complicated definitions, not only from the research side, but then also from the policy side. So for example, you can see one of the prominent definitions would be sudden onset occasion, serious disruptions to routines and collective units. This is one definition that I really like, that disasters should be defined by the people who experience the disaster themselves. But then we also have these policy legislative tied definitions of disasters. Why might a policy have a specific definition of a disaster? Any thoughts on that? Why might FEMA, the Federal Emergency Management Agency, or the US government have their own definition of disasters that might be outside the scope of what the academic literature says? Yep. Exactly. So in addition to what we have here, so you can see, it is a can of worms. I'm opening the can of worms briefly. I'm going to close it back up because we don't have enough time to get into disaster definitions. But because of the level of assistance, what are some of the triggers to disasters that would initiate, let's say, a presidential declaration? We also have what's called kind of those official mandated definitions of disasters. So as you can see, it's not actually as straightforward as we would like or think. We are balancing a lot of different perspectives, but again, going back to the human-centered approach of studying and understanding disasters, really asking, the people that experienced it, what did this disaster mean to your town, to your community? We also have our disaster continuum, and this is another way to look at this. As I mentioned before, we are moving a little bit away from the linear kind of models and frameworks just because this is turning into more of a cyclical process. But the continuum does a very good job of just kind of outlining for you what to expect at different phases. So we talked about preparedness, right? Treating the disaster as a shock here. And then we have, and what I want to urge you to do, because this is really the leap and you guys are thinking about the different data and applications that we could be looking into this, is think about what are maybe some of the different needs across these phases, right? So there's certain information that we're going to need right away, short term, within the days. So this is when we're thinking about immediate assistance, sheltering, food, supplies. Intermediate, we move into weeks and months after that disaster event. So we're thinking about, what do we collaborate with FEMA, the Small Business Administration, state and local programs begin to come online. We're now getting more support. And then long-term, years after that disaster event. So now we're thinking about what are those continuous unmet needs? How do we rebuild property, local economies? There's likely not new programs that are being administered at this time. A lot of the attention has gone away as well. So when we think about the disaster event, typically we're also getting most of the media and outside of the community support really in these days and sometimes the weeks. But what I want to really challenge us for our discussion later is what would be helpful for communities, whether you're a policymaker, you're a local or state, federal government, to know at this long-term recovery, because this is one of the major challenges that we do have. There's a lot, of course, on the forecasting, anticipatory action, and the preparedness side, but long-term recovery can really devastate communities for a long time, really trying to recharacterize, restore things before the disaster unfortunately happened. I'm going to talk briefly a little bit about our perceptions of risk. So risk has become a very interesting element of our work, as well as how we try to engage the public. When we get into the idea of mental models and how people think about climate change, how they think about disasters, this really plays a core role at that dimension there. So we started off in the disaster space with a very simple calculation of risk. We would say in communities, and this was something that years ago even I was teaching. Risk equals frequency. Risk equals hazard times frequency. That was the equation, right? Just very simple. Why might that not be enough? Any thoughts on that? So again, that equation was risk. So risk equals just the hazard times the frequency of that hazard. Any thoughts of why that might be a limiting approach to risk? Yes.
Hazard is pretty like one-dimensional, pretty like who is the hazard for, like at what time scale does it happen? Like different hazards, whatever response. So it's just like hazard seems like a very singular thing for like lots of problems.
Great point. So essentially we saw the evolution of a single hazard approach to what we call all hazards or multi-hazard approach. So looking at different types of hazards that a specific community might be vulnerable to. The level of frequency is changing quite rapidly. So this idea of risk was not necessarily painting the whole picture, But then going back to kind of that human phenomena, the human dimensions there too, this is kind of a more encompassing idea, but then also another call to action for us of how do we create more informed preparedness decisions when we expand the definition of risk beyond just knowing the hazard, knowing the frequency. So here we have risk is a combination of hazard and exposure. We both have our natural hazards here, so earthquake, flood, landslide, lightning, whatever it might be. We have our human-caused hazards, so it could be current conflict intensity, projected conflict. We also have vulnerability, so what groups and socioeconomic situations are most exposed to that risk and to that disaster. So we're not just thinking about that immediate impact of the disaster, we're thinking about inequality, economic dependency, thinking about people having to mobilize uprooted individuals, food security, other vulnerable groups, but then really importantly, coping capacity, because the more that we kind of either discount or don't necessarily take this all into our equation, the longer that long-term recovery is going to be because we're addressing those shocks. So we're also thinking about governance at the institutional level, disaster risk reduction. We're thinking about access to healthcare, access to water, sanitation, hygiene, physical infrastructure, et cetera. So how can that withstand a changing risk landscape, a changing hazard landscape, changing frequency, as well as multiple hazards, right? So risk has definitely evolved, and unfortunately, a lot of our research, a lot of our work has also evolved to begin to think about these other nuanced variables here. One way that we also prioritize a little bit around what we need to get more informed information on would be a FEMA framework here called the Community Lifelines. So the Community Lifelines really narrows it down to different subsets of the sector that we say need to be stabilized at that immediate shock of the disaster. And these are things that we kind of take for granted because during those blue sky days, they're just always on, right? But once the disruptive event, hurricane, fire, whatever it might be, you begin to see some of these turn off, right? And then the more that they turn off, the difficult it is for that community to respond to that disaster event. So then we're thinking about, you know, what do we need to know about safety and security? So this is law enforcement, fire services, search and rescue mission, government services. We have food, water, shelter. So how do we make sure disaster survivors, the folks that are supporting disaster survivors have food, water, shelter, agriculture, health and medical services, patient movement, public health. And you can think behind the scenes of all the different types of information exchanges that are occurring across each of these lifelines, let alone all of them together, right? So we need to know energy as well. So what's the status of the power grid, different fuel, our transportation systems, highway, alerts, 911 dispatch, responder communications, transportation as well, the status of highways, mass transit, railway. And then, of course, hazardous materials. So these are all things in blue sky days we should have a good understanding of the landscape of, but in gray sky days become really exceptionally important because we aim to do what's called stabilization, which means get each of these lifelines back online as soon as possible so we can, again, mitigate the disaster impact. So we're going to take a quick zoom into how people think about disasters and really start from there. Because we can come up with some very innovative tools, and Shuyang is going to talk a little bit about some of the progress and innovation in how we're communicating data, the translational science piece of disaster preparedness. But then we're also up against perception, knowledge, attitudes, and beliefs at a national and global level around, let's say, climate change, but then let's also say risk, and that is this going to really happen in my community? So that's a lot of the basis of my research has really been on the behavioral side of this. And I did a study that was looking at how emergency managers in the United States think about climate change. Emergency managers are really this like unsung hero profession that is responsible for those 4 phases that we talked about. But climate change has always been kind of this topic that has not always had necessarily the top-down support in emergency management communities. So it's very important to understand the folks that are going to be dealing with the severity of climate impacts, preparedness, response, mitigation, recovery, how they're thinking about these things. And one of the interesting takes on this was from a key informant named Wallace here about, you know, they're constantly having to grapple with both a micro and macro balance. So they're thinking about their zip code or their backyard, but then they also have to think about these things in more of a global macro level. So you can see one quote here. This is actually a key informant from the South. He says, so far, I've seen a lot of people, especially here in the South, they're starting to look around and go, you know what? Yeah, we haven't had these. You know, it is happening more. These storms are kind of getting worse. And he mentions that, the US does not necessarily have one macro level consensus, but rather a collection of micro individual understandings. So when we think about the types of applications, the type of risk and hazard identification that we can give to people, do we have that balance of toggling between kind of the micro needs that maybe Wallace needs to engage his community down the South, as well as the macro needs to really get that true understanding of what is going on? So just one example of how we would do this. Just briefly on mental models, this is going to be a framework that that I've used quite a bit to just kind of get an understanding of how people think about climate and risk. This is going to be not necessarily the most important right now, but essentially the takeaway here is that everybody can kind of contains their own either somatic understanding of what climate change is, but even disaster types. The role of experience and firsthand experience can shift that mental model, but they're constantly testing new information based on the mental model that they have kind of committed to memory or to belief. This comes actually from a lot of the computational side. I have a cognitive science that was trained by a computer scientist. So it's been kind of a nice parallel between how people think and the ways that we can analyze it. One thing that we want to take away from this and when we provide translational science and data to folks is that we're balancing constantly the knowing that versus the knowing how. So, this is going down to the idea that there's multiple types of knowledge. So we have declarative knowledge, which means, we can potentially state a bunch of facts, or we were taught in school to name the greenhouse gases. But then we might have a barrier with knowing how are those greenhouse gases contributing to CO2 emissions and what are those impacts. And when we think about kind of the national and global sample here of thinking about the different types of thought, we see people at very different levels, although sometimes in the translational piece, we treat everybody as though they're at the same level or need the same information across the board. And oftentimes in our work, we'll hear, I'm not a climate scientist. I don't want to be a climate scientist. What do I really need to know? And when we're thinking about what types of applications, tools we can equip people for community preparedness, one way to look at it is, who needs to be aware of what's going on? There's probably a universal awareness that's needed around disaster preparedness, but then maybe those folks that are in that awareness category might not necessarily need the performance data or be able to use the data to do a specific action. And then who are the people that are managing those processes? So that tiered system has been a way in which we approach community preparedness, knowing that we might lose people in this awareness segment if we're treating it more of like a management, like you need to become this expert. What are the ways that instead we can put people on a pathway to be adaptable as information changes, to understand what's going on in their communities, but then also combine both kind of the knowing that something is the case versus knowing how to do something here. This is some examples, just some fun ones fresh off the press. Each summer, we do a program up in Vermont with some high school students and each summer there's a mental model challenge of how they're thinking about climate change, what are the connections they're making. This is very much a just semantic model where they're just kind of listing out concepts and connecting concepts. If we were going to do mental modeling the way that it was intended to do, then you would add kind of the prepositional networks in there where you'd be looking at connecting cause and effect. So you'd be doing if, then, if, then, if, then. It gets really messy, but it goes to show that, stemming just from this broad topic, we have multiple understandings, initial thoughts around this that are all shaped by one external phenomena, but then the internal psychology as well. And one way that we also know to how we're going to better engage people on these themes is trying to get a head start on how they're thinking about it. We're going to be a little bit short on time because I want to make sure that Shuyang has plenty of time to do this. So I'm going to kind of just take the main takeaways out of these slides because I think Shuyang is going to really talk about the cool stuff. One of the things that we're thinking about with disaster preparedness are the choices people are making. And this comes out of the behavioral science and starting to talk about choice architecture. So first and foremost, when we talk about, are people going to act on risk behavior or preparedness behaviors, we're thinking about what's the goal, and that behavior tends to be goal-oriented. We have two different decision theories. One is the normative decision theory, so what people ought to do and to get the optimal choice, versus the descriptive decision theories, what people actually do. When it comes to climate, I'm sure you can imagine, we kind of see this model not necessarily work perfectly because, in an optimal choice, we would want to do to be sustainable. We would want to be environmental stewards. And what we might do instead, because of many different factors, is something very counter to that or different. And this gets into what we call the intention action gap. So we might have every intention to do something that would better prepare our communities, our household, whatever, for a disaster, but the action might not match. But why might the action might not match? Why might we have an intention action gap for disaster preparedness? Yeah. Misjudging risk is a big part of it. So we'll get to that in a second, but exactly, the intention might be there. The action we might not see the trade-off immediately. So yeah, really great point. Any other reason we might have an intention action gap? Yes.
You may intend to help the environment somehow, but it could also seem like too much work and sort of a hassle.
Exactly. Very good point. So is it accessible? Is this something that is going to be a lot of effort, which is going to lead us to our next slide? So we have different components of value, and we have to think about this in terms of our climate actions, our preparedness actions, and some of them come down to payoff. So we're talking about it. Is the reward, what is the kind of reward? Is it monetary, non-monetary? How much is the award? The probability, is there a high likelihood of actually attaining that award? Effort cost was brought up. So how long are you willing to wait, and how hard are you willing to work for the reward? The context matters, the time of day, the weather, internal states, and then very subjectively, preference also matters. So all these go into factor around thinking about what might be the difference between that intention action gap, but then also the normative and descriptive decision. And these are all very human traits that apply to many different things. But when we think about this in climate, specifically, it becomes much more complex because we're dealing with longer timescales. We're dealing with a lot of different messaging. Context, of course, matters quite a bit. Preferences matter quite a bit as well. So some of the major barriers that we see with climate reasoning in general, and becomes really important with when we're presenting data, is causal reasoning being a major piece. In most things, causal reasoning really illustrates the fact that cause becomes before effect, right? So the fact that I throw a ball across the room, it hits the wall, knocks over that water bottle, you're going to attribute that I am the reason why that happened. The effect was the water bottle fell on the floor, but it was pretty straightforward. Where it comes to climate, because some of the impacts and the effects, and oftentimes manifesting in these disaster events that we're talking about, are far more spread out in time and space, this is where we do begin to see a disconnect between cause and effect reasoning. Specifically in the US, this is actually one of those very important and intricate pain points around reasoning, because cause is where we get hung up, right? Cause, you might hear the debate around anthropogenic climate change. Are human behaviors, actions really contributing to it, right? And a lot of it goes back to this causal reasoning, this cause and effect chain. And then what we're seeing really interesting in adult climate literacy is that effects are becoming more or less accepted, whereas cause still becomes a point of contention or debate. Because the effects they're seeing in their floods, they're seeing in fires, they're seeing how hot it is out, even outside today, right? So we're beginning to try to reconcile this cause and effect. Goes back to those different types of knowledge that we were talking about earlier. The other thing that we want to talk about as well is likelihoods and probabilities when we're talking about risk in general. From the Oxford Handbook of Thinking and Reasoning, likelihoods and probabilities has a whole dense chapter of why people tend to misunderstand and interpret probabilistic statements, and kind of determine and use them more as deterministic magnitudes and probabilities. So in the disaster space, we're really kind of guilty of that in some extent when we say things like the 100-year flood. It goes into what's called the gambler's fallacy. Has anyone heard the 100-year flood before? Right. Anyone have an idea what the 100-year flood is? Want to share? Dan?
Sure. Yeah, so when you're talking about a lot of these events like floods or droughts, you want to say, what is the biggest thing? What is the size of the thing that would happen if, I rolled the dice and it would only happen 1 out of 100 rolls. So after 100 years, if I looked at it, what would be the size of the thing that I would expect to have happen only once every 100 years?
Exactly. So this becomes an area of confusion, right? So some of our previous projects, we actually went around the country with a training program where we were talking about likelihoods, probabilities of certain disasters. And there's, even on top of a 100-year flood, there's a 500-year flood. And we would go to a community and they would say, hey, we had a 100-year flood just last year. I think we're going to be okay for a while, right? And why might that be a misconception? It's going to be a misconception because they're really feeding into the gambler's fallacy, because they're thinking in terms of, you know, I had this event once, I'm good for 99 years. That's not the case. The other thing that's kind of the backdrop of the 100-year flood is that's a 1 out of 100 chance on an annual basis. So we kind of leave that tagline off. So we also have a lot of folks that are confused about this because they're thinking, you know, a 100-year flood won't happen to me in my lifetime. And can't tell you how often we hear that. And unfortunately, we do need to kind of change how that's being phrased. So just an example of why how we're describing likelihoods and probabilities becomes so important. The other thing that we talked about a little bit earlier in the input is self-efficacy. So are we creating and designing tools that make people feel empowered to make their decisions, to think about their capabilities to do something around climate, to think about the goal-oriented behaviors. So we're literally also looking at the level of efficacy, agency becomes really important. So we can give people as much information as possible. If they don't know what to do with it, or they don't feel empowered to do anything with it, we do run into this gap as well. I'm going to skip over this a little bit, but this is essentially a key informant from the study as well. An emergency manager with 20 plus years of experience, brilliant individual, but some of the issues that he has with climate and climate science. So he would say, you know, it takes a lot of theory becoming reality before really buying into it. He wants it on a local practical level, and all these other types of things that he might be skeptical about. He mentions the 50, 100-year floods here. So he wants to be able to prepare for 5 years, 10 years, 50, 100 years, and figuring out how. A lot of it is scale. So how can we better communicate scale? So not the scale of the severity of what's happening, the change in threats, but more the scale of someone's ability to change it. So going back to that agency piece there. So the reason I want to show that slide is that not everybody might be on board or have consensus yet. And how do we better equip folks even for that agency if there is that kind of different perspectives on these things. So in short, emergency managers are definitely feeling the impacts of climate change in the new severity, magnitude, scope of disasters, disasters happening in places where they historically haven't had them, and thinking about those preparedness measures that they could have. They voiced a preference for localized information as practical and relevant, but then also talks about social and political context. And then one thing that I think is a really important call to action is how can we better enhance capacity and long-term thinking, being able to think about timescales in the past, short-term, as well as long-term into the future, so that these can actually be put to practice, operationalized into their emergency management plans themselves. So I'm going to pass it over to Shuyang to talk about some of the innovations that are already addressing some of the issues here.
Thank you, Josh, for all the valuable information. So as we discussed earlier, the emergency managers view disasters as the recurring event with 4 key phases: the preparedness, response, recovery, and mitigation. So each phase innovates various data and data method, highlighting the critical role of data in the, sorry, it's the, okay. Can you hear me now? Highlighting the critical role of data in effectively managing disasters throughout these stages. So this preparedness phase, including planning, training, educational activities for events that cannot be mitigated. First, I want to share a preparedness data set at the national level. Here is the National Risk Index. We also call it NRI. It's an innovative tool developed by FEMA to help us understand the community risk from the natural hazard. So this platform highlights which community in the US are most at risk from 18 different hazard by the gradient map. So the risk here indicate the potential negative impact from national hazard. And this risk is measured through 3 main components: expected annual loss, social vulnerability, and community resilience. So the equation here is expected annual loss times social vulnerability divided by the community resilience. So the expected annual loss, it quantifies the average economic loss in dollar due to the natural hazard each year. And the data from the index come from a variety of organizations. For example, the expected annual loss come from the mix of federal, state agencies, academias, and research institute. The social vulnerability index at the right side is come from the CDC and also the Agency for Toxic Substance and Disease Registry. And at the left side, we can have the community resilience. It was come from the University of South Carolina. So due to the extensive work involved in gathering the census data and calculating the index, the latest update of the Social Vulnerability Index is using the census data in 2022. However, the latest community resilience data is using the data from 2020. So this highlights the challenge of maintaining timely and consistent updates for all these components. So on a local level, the time issue is a little bit easier to solve. For example, the physical camera are used to monitor the California wildfire. The cameras constantly scan their surrounding area in a 2-minute rotation. So once the system detects an anomaly such as the smoke-like sign, it will red flags it. So the AI technology play a very crucial role here, analyzing the images and identify any changes. The data is also publicly accessible, allowing anyone to watch the live feed online and to see the real-time weather condition. So on the left side, we can see a screenshot I took from the website. And once you click on the snapshot, you can have a more zoomed in version, providing very detailed information and situational awareness to help the communities prepare and respond effectively. So it is also crucial to gather preparedness data from the community level, as it is very subjective and highly rely on individual opinions. So FEMA conducts its annual National Household Survey to capture this information. The latest survey was conducted from February the 1st to March the 14th, 2023, using a web-based platform in both English and Spanish. A total of 7,604 responses were received. So respondents will ask general questions like about disaster and pandemic preparedness. So this slide shows a summary of the information, whether those respondents understand and they feel adequately prepared for disaster actions in their community. And for the response phase, it occurs immediately after a disaster. During this phase, business and other operations do not function normally. Personal safety and well-being in an emergency and the duration of the response phase depend on the level of our preparedness. So response data help us to understand the extent of the disaster's impact on the affected area. Here is an example from the ASRI team, which conduct a building damage assessment following the Lahaina wildfire in Hawaii. So upon obtaining the post-disaster imagery, the team manually inspected 500 buildings, classified them as either damaged or undamaged. And once the model was refined, they used ArcGIS to run the deep learning model and produce the damage assessment. For the Lahaina fire, a dashboard was created to visualize the results, assisting the organization in guiding response and recovery efforts and informing the public outreach. And during the recovery phase, the restoration efforts occurred concurrently with the regular operation and activities. So the recovery period come from a disaster can be prolonged. It involves extensive information on how individuals can secure financial and mental support. So every community has its own asset and resources, making the asset map very important here for the recovery process. Asset mapping document the resources, highlight the community strengths, and incorporate them into recovery goals. So it creates a reference tool to locate essential resources and reduce the barrier during the disaster recovery. And for the mitigation phase involves the actions like to prevent and reduce causes, impact, and consequence of the disaster. So an excellent example is using architecture software to optimize the building design by analyzing solar radiation. So it allows us to design buildings that can fully take advantage of the natural light and reduce the need of artificial light heating and lower the energy uses, which ultimately mitigate the impact of climate change. So there are some current challenges in the categorized by different phases. So for the preparedness part, as we mentioned before, there will be errors in the collection process, such as the malfunctioning of the equipment and the human error and some inconsistency of the method. And also there is a significant variability in the data quality at the local level. For example, the New York State have a very comprehensive database. However, other states might not have such robust data source. And also another critical issue is they don't have frequent data updates. As we mentioned before, even though the social vulnerability index was updated in 2022 or 2024, it is used census data from 2022. So it didn't reflect the very current conditions. And moreover, we are over-reliance on the data-driven decisions, as Josh mentioned before. The FEMA 100 and 500-year floodplain is proved to be inaccurate, but we still are using that for decision-making process. And for the response phase, we have the errors in real-time data collection, and sometimes a lot of very good database is privately owned. We don't have accessibility to that. And also for the data integration, there are a lot of sources from sensors, social media, and official report. How to integrate them, it will create a lot of error and complicate the overall response efforts. And in the recovery phase, there will be incomplete damage assessment and financial loss estimation errors. So this inaccuracy often comes from the financial estimates being limited to insured asset. However, it overlook a huge amount of uninsured property. And also we lack of long-term data for the recovery analysis. So it makes it difficult to learn from the past event and improve our future recovery plans. And for the mitigation part, we have limited access to high quality historical data, and also the complex algorithm and models in predictive modeling will cause a lot of uncertainties and conflict results. And moreover, the community generated data, like what we mentioned before, the survey, the citizens science project is frequently underutilized, despite its very high potential value in informing the mitigation efforts. So here are some training examples and concepts I want to share, and I think it will make a very big impact in the climate resiliency field. So one example is the Health Map. It's a text and information sharing platform where people use that since the COVID-19. So it collects data every hour and uses AI to scan social media and other data resources. This helps provide the public health organization around the world with early warning and real-time disease outbreak monitoring. So it has over 90% accuracy rate, which is pretty high. And another great example is the ESRI disaster response program. So this program offers a real-time update of the remote sensing data, so to enhance the public information and awareness. It also provides software and technical support for emergency GIS operation. This ensures people to get the help they need and to understand this situation, make the informed decision, and respond more effectively during a crisis. And the last concept I want to share is the urban digital twins. So these are more than just 3D meshes. They evolve from the digital replica of the physical world into the integrated platform with additional data and analytic capabilities. So tools like this can potential to disrupt the industries and significantly impact life. So they can analyze various subjects such as the identifying behavior patterns in cities and that crowded with vehicles and pedestrians, or understanding how a building structure affect urban heat dynamic. So supported by software tool, the digital twins simplify the complex analysis through the digital visualization. So Singapore has developed several digital twins. So One example is the One Map 3D by the Singapore Land Authority, which is publicly available and interactive. This platform allows the user to perform the shadow analysis, as you can see at the right side, and also the view perspective from different windows at the left side we can see. And also they can conduct property analysis. So by layering more information onto the map, the One Map 3D enhances planning and decision-making process, provide valuable insight for urban development and management. So the future holds exciting possibilities for how data and AI can enhance climate resiliency. There are some of the potential advancement I'm thinking about, such as the AI-enabled disaster notification system, the real-time damage assessment dashboard, individually customized toolkit for disaster response, community-specific models for various disasters, different climate scenarios, simulation, and forecasting systems. So now I want to ask you about the question. What else do you think it could be in the potential future?
Any ideas? Because we're going to open up the discussion portion, but taking everything that we talked about, if this was your first time looking at disasters and this level of detail, the context, the background, and some of the work that you've seen or get exposure throughout the summer, any ideas that come to mind? Anything that we're missing on even on the disaster side that we should have on our radar? I think this is a great opportunity to have that discussion or dialogue. Any thoughts? This is kind of full ideation. There's no bad idea here. Yeah.
You reference this framework of blue sky days and gray sky days, which I guess defines like hurricanes as a disaster.
Yeah.
I'm curious how you think about red sky days or extreme heat as a hazard. Oh, sure.
Clearly
Yeah.
competing with someone.
Yeah. How do you think about extreme heat as a hazard? You know, we're experiencing a bout of extreme heat now. It's the deadliest form of extreme weather. So how do you think about this ongoing disaster of extreme heat and how to adapt in urban environments like New York City?
I could start and then you want to chime in? Okay. Yeah, so I think as we speak, I think there's a extreme heat workshop going on across the street. So it is definitely getting a lot more attention because we're feeling it. And I think going back to the behavioral science side, it's becoming less of that abstract hazard. It's going to be kind of on this annual basis of these summers that are this hot, right? And I was actually supervising a research project last year that was looking at state of Connecticut and what they're doing with their heat warnings and systems. And part of this is also the communication piece around oftentimes when we're talking about heat, it's just the warning and not necessarily like the preparedness, the action steps to do. From the planning side of it, you know, we're seeing a combination in terms of looking at nature-based solutions, you know, how are the cities, the towns built to kind of have natural cooling systems, but then also thinking about the investment for real cooling systems, accessibility, equity. So there's a lot there on the social dimensions that play a role, but heat, as you're mentioning, is going to be another one of those hazards that because it's on the doorstep, or I like red sky days as a great way to phrase it, that I think we'll get a lot more attention to because people are seeing the impacts directly. But Gianni, anything you want to add?
And also in the architecture realm, so the plannings, they ask the new architecture constructions to have more like environmentally friendly materials to be used. And I think last year they allowed mass timber to be used as the facade for the architecture itself. Yeah.
Yep. Oh, be careful. They're going to start drilling right when you start speaking.
Thanks so much for the talk. I really loved everything you all were saying. So in my past life, I was actually a civil servant in the New York State government, the legislature. I was with the government during COVID. I was, you know, in those days, talking a lot with folks from NYSD, Department of Health, doing oversight, investigations, that sort of thing. It really seeing firsthand a lot of what I would argue is the neglectful areas in our state's governance in response to these types of, you know, disasters of natural origin. Another example is in June 2023, I was part of a briefing with NISO, the New York Independent System Operator, which for those who don't know is basically the quasi-governmental agency that does oversight and studies the reliability of the New York State electric grid. And a lot of what they were prognosticating was in the summers, forthcoming 2025, 26, 27, that we have a very dangerously narrow margin between baseload energy generation and energy demand in the downstate area, caused in part by the heat waves, but also challenges in energy generation from the closure of the Indian Point power plant in 2017 and delays in getting Champlain Hudson Power Express Line hydropower from Canada down here to New York City. So all of which is to say, a lot of what I saw, which may not necessarily be what you or everyone else has seen, is sort of a challenge in getting policymakers towards preemptive planning, as opposed to, we'll just wait until the disaster happens and then take action after the fact. So I'm wondering, just from, your perspective, what has it been like on the ground in terms of getting this paradigm shift of, we can't just wait for the bad event to happen, we need to act preemptively?
Yeah, I think for a long time, the preparedness work has always been similar to what you're describing, very much a reaction to an event. There was this study's probably out of date, but they was showing that, for like local government officials, state government officials that were running for office again, there was more incentives for them to run on a response platform or than a preparedness platform, because there's a chance that in their term there might not be a disaster event where they can kind of cash out on being the one that prepared the community. But if they're the person that's in the vest at the response site, it does have some political social capital as well. So there's a little bit of that, but more importantly to that question is I think we are beginning to see a lot more attention to this. One, the billion-dollar disasters, we're seeing this as quite the expense at the local, state, federal level for governments, because oftentimes these local programs will have to come in for the unmet needs. We're straining a lot of resources on the response recovery side. So if we can kind of better balance that into preparedness, that's also gotten a lot more attention and support. It has become very complex because even on the climate discussions with emergency managers, there's a lot more attention to response because there is more funding for response activities than there are for preparedness activities. And seeing how to kind of, unfortunately, I think the learning by doing, the frequency of these events is going to eventually shift that to be more of a balanced portfolio across the 4 phases, more to preparedness. But right now it is still very response heavy. And unfortunately, I think we're just going to see these direct impacts add up to the point where we do need to adopt more of that cyclical framework as opposed to linear. Because the reason why we have so much focus on response at that stage is because we're just anticipating that shock, and then we go through the motions of that linear fashion. But more and more communities, I think, when they're seeing these events kind of happen in their community within 1 to 2 year to 3 year thresholds, we're hitting more of that cyclical understanding that, okay, we just went through a response, let's move into mitigation, let's move into preparedness. And I think mitigation is actually going to see more of the funds go towards that than preparedness, which they're related and they're going in the right direction, but then shifting from response, as you mentioned. It's very complex, though, as I'm sure you've experienced. Yep. Any other questions, ideas? Yeah, in the back. I'm sorry, I think the microphone. Yeah, I think so. Correct me if I'm wrong. So what would we need to do for like the real-time damage assessment dashboard? Yeah. Do you want to talk about that? So what types of data would we need for the real-time damage assessment dashboard in the second bullet?
So currently we have the GIS data and the census data that we already have, but because the large amount of compute resources we need to use, so we cannot have the real-time data for example, the building damage assessment. So it cannot update real time. It can only, like, once you take a picture, you upload online, you rasterize this picture, and then you can know which buildings are damaged. So is that possible to have for example, platforms that can collaborate with the the Google map, and we can see the real-time damage of this area and something like that.
And part of the challenges as well is just how well that data syncs up. We see this with communities all the time where they'll say, this organization has that data set, but they won't give it to us. This organization has this one. So that is also another complication that during the Blue Sky Day, we would need to kind of coordinate better around who can share data sharing, disaggregating the data, aggregating the data. So it becomes something in theory that makes a lot of sense that we should have this in real time, but in the practice of it is much more of a negotiation and back and forth. But yeah, really good question. Yeah.
I have a question about data as well. And I think, I think my question goes slightly into a different direction. Not so much the data that you or we as researchers collect, but the data that could be contributed and volunteered by communities on the ground, like really going into communities that are continuously struck by natural disasters, Puerto Rico, for instance, right? And maybe collecting together with organizations and residents on the ground, I guess more qualitative stories about what their experience is and having a sort of an arc to trace how people maybe experience disasters over years or decades. Is that something you're interested in doing? Is this something that you think could helpfully inform this kind of research? And if so, at all, maybe not, but if that is a valid approach, how would you, what is the mechanism or process by which this could be done?
Yeah, really important question because as I mentioned, by the time we get to long-term recovery, like a year after the disaster, oftentimes we're losing, unless you're living in that community, you're working with that community, or there's some type of interaction, we kind of lose track of what's going on in their everyday lives. And I'm going to give a very non-empirical answer to that because I've seen a really good example. I was at our Institute of Ideas and Imagination last year, which brings a lot of the humanities together to talk about scientific issues. And that actually came up, and there's a photographer named Maxime Richer, who has a whole exhibit called Paradise. And his approach to that exact problem was, I want to stay and keep track of this community for the duration of their long-term recovery. He did it through images, he did it through storytelling, he did it through capturing all these real-life stories. And one of the things that we did together was we had kind of a disaster talk, and then we went to his exhibit, and people were immersed in the disaster survivor's story. And it was probably one of the most like profound examples of speaking to the lived experience of the disaster survivors that I've seen. I'm sure with where we're headed with technology, there's going to be other applications where we can still have that immersive thing element, because I think with disasters, risk perception, we don't want people to have to learn by like having to have that vivid primary experience. But if we can increase the density of those secondary experiences, I think that it has a really strong message as well. But I think the best example I've seen so far has actually come from the arts on how to do that. But I'm sure maybe that'll be a good idea and challenge for our folks. Yeah, Dan.
I just wanted to say something about that is, I've just moved, my group has just moved to NCDP, I think officially this week or last week. And one of the focuses of what we're working on together with computer science is this kind of question, is how do you have the communities contributing during a disaster and before a disaster, because they're the only one, you're the only one who really knows what's going on in your household and your community. And we need to reconcile these things. And so there's a lot of things we're trying to do with phone games, with town halls. They're all very highly technology intertwined so that those go directly into the maps and the models and the actions. And it's something that's, part of it is playing games for hypothetical situations. Part of it, it's too boring to call a game, so there's exercises in town halls. But a lot of talking about past events, what you would have done if you'd known something in advance, but also during this event, how does it relate to a past event? And understanding what people's needs are to try and work through these things. And I think that's going to be something very, I mean, it's exciting enough that I have a new office now with my team, and working with computer science and AI plays a role in it, but actually this community and human intelligence is really what needs to drive it. And so I think that's going to be something that's the more exciting part of this kind of stuff as we move forward. Is this very interactive element.
And I should have introduced him earlier. This is Dr. Dan Osgood, brilliant economist and really working on disasters with us as well. A lot of pioneering ideas that we're going to be collaborating on, combining behavior, technology, systems. So, yeah. All right, I think, are we good on, we're out of time? Okay, I want to make sure we wrap up on time, but thank you all so much. It's a pleasure being here and stay in touch.